Well, let's continue with the session on studies. It's a short introduction. I'd like to briefly look at how feasibility studies and other studies are found in the project cycle. Then we look at some typical aspects of feasibility studies themselves, to briefly highlight some important concepts. And then we have a sort of first look at what modeling, financial modeling, what typical parts we find in financial models, and how they are generally speaking built up. I should say that this is a very so brief and basic introduction. So in the period, especially January and February, we will be looking in more detail at different aspects, the especially financial assessments, as a setting up a financial feasibility study, setting up models. I'll try to prepare some exercises so that we can have some more interaction, hopefully some more practice. So projects. A project is basically it's defined as a piece of work, an activity that has a clear start and a clear end, and it has a particular purpose, and that is a bit of an academic definition, I suppose, but it's important to realize that that project has a start and an end, and especially when looking at the financial analysis, this is quite an important aspect. I'm sure that you are familiar with some project cycle diagrams. This is one that I like myself. It's from a feasibility study manual of UNIDO that I use myself. There's other types of cycle diagrams, but they more or less all have the main phases. Let's say pre-investment. That includes especially a range of studies, including feasibility study and pre-feasibility study, starting with opportunity studies and ending with appraisals of studies that were carried out in this phase. And come to the investment phase, where let's say in our case an energy production unit is planned and constructed and started, and the staff is trained, startup, and then you get to the operating phase, in which the electricity is actually being produced. And then if we talk about a project with a start and end time, then you would more or less talk about, let's say, starting at this point and then ending at the end of the cycle. Looking at some of the studies in the let's say the pre-investment phase, so the blue-gray one. Could start with opportunity studies, which are very broad studies looking at the very basic conditions for types of projects in a certain country. looking at, for example, the potential demand for certain products, energy products in our case, looking at available resources, looking at the investment climate, looking at basic policies where they are conducted. If there is if opportunities are there and that's been shown, then we could look at pre-feasibility studies, which are of course preliminary assessments of project potential. Say looking at different project alternatives, and they're usually produced as a justification of getting into a more detailed feasibility study trajectory. Then the feasibility study itself is let's say the detailed assessment of the project feasibility from a technical and financial, organizational, environmental, and legal point of view, with the ultimate goal of, let's say, making an investment decision. And if we really have sufficient detail and so-called objectivity, so let's say removal of the subject, that we can use it for attracting financing from investors, lenders, and then grant providers. Then we talk about a so-called bankable feasibility study. So you really need to have full support for all of the variables and parameters that are presented. You need to have documentary proof, quotations, letters of intent, policy documents. So that's say any potential question that investors or lenders may have would be covered. At the end of this part of the cycle, you could have a due diligence step in which different project participants, whether that's, for example, investors, or whether that is let's say banks, or let's say suppliers of feedstock, they can have their own appraisal of the outcome of the studies to see if their own objectives are met, and whether the assumptions of costs and benefits are actually supported, and whether the risk level is acceptable. And then, as mentioned, we can see a whole range of different support studies for feasibility studies. There could be market studies looking at the particular demand for products and potential price levels. We have resource studies looking at the availability and prices of resources needed. You can have some pilots testing of technology, laboratory trials with different resources. You could have scouting, scoping studies at project locations. And you could have, let's say, social and environmental impact assessments, which are often required for especially larger scale projects. Feasibility studies, this indicates they have different viewpoints. You have let's say the technical viewpoint, looking at how to produce and deliver a product. In our case, energy. Looking at what types of, let's say, what would be the outputs of the system, capacity and the production. In the case of bioenergy, that could also be, let's say, byproducts, maybe heat. Looking at the inputs, whether it's, let's say, feedstocks for for bioenergy plants, or let's say staff requirements, parts, maintenance. Looking at production processes, say basically the equipment that is needed, and the operation and management of units. You can have the location as a subject of technical feasibility study. You could have the financial perspective, of course, looking at the net benefits of a project in relation to the investment. And if we look at the financial study, then it's usually from the perspective of the project owner, project owners, or let's say investors. If you look at the economic feasibility study, then we look at the benefits of a project to the economy, say to the country, to society. We can look at the organizational aspects of a project, so the different roles of project participants, and the capacity to fulfill those roles. That could be for the actual operation and or the maintenance of equipment. It can be the supply of feedstock. It can be the distribution of the electricity. It can be the administration of the energy consumed by clients. All different roles by different potential participants. You could have a commercial viewpoint, assessing the market conditions for projects, the market potential, the types of clients, the competition, and the estimation of the amount of product that can be sold. Basically, in our case, that would be the actual energy demand. The technical feasibility studies, as indicated, mainly looking at the type and quantity of output that can be produced over time. Let's say in different years that the project is operational. The inputs that are required and the production process, and the location and the layout of the production unit. It's quite common to build technical models so that you can experiment with different variables and parameters and find an optimal solution, or to see what could be the risk of certain parameters or variables being different from what is assumed to be the base case. It should result in a basic project design, say indicating well, basically these aspects, indicating what is needed in technical terms, say equipment, but also inputs, and what are the outputs of it. Identifying technical uncertainties and risk, and how they could affect the output, potentially also the inputs of the system, and the planning of the implementation of the project. For a typical is a bit of a tricky subject here, because I believe that every project has its own features, especially larger scale projects. Will always vary depending on the location, the conditions, the the country, for example, the resources, etc. You could have an assessment of the site when the project is planned. You would have typically an assessment of the energy demand, especially for isolated systems, mini grid systems, or systems at individual users, captive power in industry, for example. You need to have a very clear understanding of the energy demand that would need to be met by the system. Have a close look at the resources, whether that is hydropower resources or solar resources or bioenergy feedstocks or wind resources or whatnot. To have a clear idea of what is the potential. They have at some point you have selection of the right project concept. And that's a bit of a well, I could actually say it's a bit of a process between different steps, where you look at what is possible in terms of available resources, and what is needed in terms of energy demand. But at some point, let's say some project concept is selected, and then let's say a model is built up around this project concept, and let's say the different technical parameters and variables are set up to fill the model, so defining the outputs and the inputs. Then basically you go towards the definition of what is needed for the project in terms of technology and equipment, and you look at operation and maintenance requirements over time and the human resources required for this. I should say that depending on the scope of other parts of the study, there could be other aspects to be added, for example, environmental, or to some point also organizational aspects. Financial feasibility studies, they are basically focused on assessing the financial features of a project with respect to the investment required, not just let's say at the start of the project, but also in later stages in the project. Let's say reinvestments, replacement of certain production assets. Costs and benefits, let's say operating costs incurred for producing energy in our case, and revenue basically for the sales of electricity and sometimes heat, resulting in certain annual cash flows. Hopefully the benefits of the project are higher than the cost, resulting in positive cash flows, which then should cover the investment costs at a certain point. Project financing. So how are the especially the initial costs of a project, how are they covered by equity or by loan capital, or possible also by grant funding. Then you look at income for the project, basically making income statement projections for each of the years of the project. In some cases also making balance projections, giving an indication of how the balance of a project would develop over time. Very common is the calculation of financial indicators. Simple one is the payback period. A bit more complicated are the internal rate of return and the net present value. And looking at let's say it's typically also look at the return on investment. And in energy projects, it's quite common to look at levelized cost of energy in order to compare this with say, other options for energy production. We'll be having a closer look at the later stage. As with technical studies, it's with feasibility studies, financial feasibility studies, it's quite common to build a model, to use a model, so that you can manipulate variables and parameters and see what are the consequences for the let's say the financial performance of a project. So how does, for example, rate of return or present value, how does it change if we change some of the underlying assumptions on variables and parameters. It's quite common to make a link with the technical model, so that also any changes in the technical variables and parameters can be assessed on their consequences in the financial domain. And what is often done is let's say using an existing financial model and modify it for carrying out the financial assessment in a certain project. Here again, for a so-called typical energy project, you'd be starting with the collection and ordering of different types of information relative to the financial studies. That's your basic parameters and variables. Second step would be either the construction or the adaptation of a cash flow model, financial model, which you can use for the assessment. Then you usually have some iterative optimization steps. Let's say looking for the best way of defining the project, and that could mean that, for example, some technical parameters may need some adjustment. Maybe scale of project may need adjustments in order to arrive at financially feasible project. So this is a bit of an iterative process. And let's say once this has more or less finished, then it's common to have a look at how projects can be financed. It's indicated whether that should be done by just by equity, so by a private investor, for example, say a company wishing to undertake an energy project at their own premises, or it could also be a sort of a greenfield project that is financed by different financiers and by bank loans, and possibly by some grants capital. In the end, sensitivity analysis is quite common to see what is the effect of variations in the assumptions on the financial performance of a project. So let's say whether uncertainty in certain parameters and variables, whether they have a large effect or a smaller effect on the the outcome of a project, whether let's say mitigating steps may be required. Important to realize that a financial assessment is not the same as an economic assessment. Financial assessment, as briefly indicated, you look from the investor's point of view. So you look at the financial project costs and the financial revenue of a project. And you look at the capacity of a project to recover the investment done by the investor. With an economic assessment, you have the whole economy of a country. It could also be a certain region within a country as a point of view, and you look more at what are the so-called opportunity costs of certain inputs. So let's say if you if your project requires a lot of labor, for example, and you have your project in a certain region with very high unemployment, then you can say that the so-called opportunity costs of your labor are can be quite low. So it means that by creating employment for people under such conditions, you actually you have relatively lower opportunity costs in your project. I'll explain that in a later session in the series. I'll have a closer look at that as well. On the other hand, you look at what the overall benefits of the produced energy can be for a certain region, for a country. So let's say the supply of energy or the improved can have a higher benefit to an economy than just the value of the project of the product itself. So if it allows, let's say, other productive activities to be developed, then the mere availability of the energy can have a very high development impact. That means that its importance to the economic situation of a region or a country can be much higher than let's say the mere financial impact for the investor. Some concepts that I'd like to discuss. I see it's a quarter to already. I'll try to be brief. We will be looking closer at cash flows, which is very important in financial assessments. Basically, it means looking at the amount of funds, of cash, that's and out of a business. Let's say you're looking at different costs and expenditures, and on the other hand, different earnings, revenues, or cost savings, which can also be considered earnings. Then arrive at some point at a net cash flow. So basically, you look at cash flowing in, you subtract the amount of cash flowing out. You use cash flow on the one hand for making sure that a project can always meet its financial obligations. So, making sure that the expenditures can always be covered either by the amount of cash that flows in from operations, or that there is a certain buffer in case of let's say temporary negative cash flows. And at the same time also looking especially at the start of a project at how much funds are needed for covering the initial investments. On the other hand, cash flow is for determining the financial indicators, like the internal rate of return and the net present value, etc. Discounting, I remember that there was a question at some point to Paul on a discount rate we used for calculating levelized cost of energy. That is directly related to the activity of discounting, and that is basically the method that you use for determining what is the value of future cash flows on, let's say, present day value levels. So determining the present value of future cash flows. And the basic idea behind that is that the value of a sum of money at present is higher than that of the same amount of money in the future. So basically, if you have $100 today, on the one hand, you can do something with it. You can either put it on a bank and get some interest, or you can invest it in a company or and earn something with it, meaning that its value today is higher than it is if you would not be able to do it to use it during this period in the future. On the one hand, on the other hand, it has to do with risk assessment. Whether suddenly inflation is rocketing, or whether the overall economic conditions in the country are becoming poorer, or whether the conditions for energy projects are suddenly changed in a country. Whether there's let's say demand risks, or let's say other entrepreneurial risk that makes that money that you have today is valued at a higher value than what you have in the future. And therefore, within the method of financial analysis, you will always look at every period in the lifetime of a project, and look at the cash flows in each of these years usually, and you calculate them back to the value of those cash flows at today's value, and then the rate at which and the value of the cash flow is changed over time is called the discount rate. Then following on the concept of discounting, you would say that a project should be able to recover the investment costs despite the decreasing value of future net cash flows. And if a project is able to do that, so that all the future cash flows discounted, so brought back to present value, if that is sufficient to cover the initial investment, then you could say that a project is economic. And if you use discounting for indicators like present value and internal rate of return, you can compare the financial performance of different projects different project alternatives, or with a certain benchmark. So let's say it should have a project should have a minimum IRR, internal rate of return, of well, depending on the investors' minimum cutoff rate, minimum rate of return that a project should have. And you could say that a project either meets this requirement or not. Net present value is one of the financial indicators that is very important in financial assessments. It's basically the sum of all the discounted net cash flows over the lifetime of a project. This is the official formula which can be used to do the calculations, but it's quite common to just use Excel formulas, or to otherwise fit this in the shape of a range of sums over the project period. The net present value can be used for comparing investment opportunities, although they should be seen in relation to the investment. So, say a larger project cannot be directly compared to a smaller project on the basis of the NPV alone, and therefore you can either look at the ratio between NPV and the investment, or also look at it in combination with the internal rate of return, which is, let's say, less specific to the project scale. Speaking of the internal rate of return, it's defined as the discount rate at which the net present value is 0. So it can be seen as the minimum rate that is required in order to arrive at an economic project. Can be seen as an indicator of the annual returns of a project for the investor. The IRR should also be seen in the length of the project. So the lifetime of the project should be indicated as well, because it makes quite a difference when you look at, let's say, the first part of a project, which some investors may choose to do, say maybe the first 5 years, rather than longer periods of 10 or 15 years, covering, let's say, the whole lifespan of a project. It can be calculated by hand. Sorry. But it's an iterative process, and it can be quite cumbersome. And you have Excel formula that can do it for you, so that but it's easier to use such formulas to do work for you. I think I indicated that it can be used as a indicator for checking the viability of a project, financial viability. Let's say if the IRR is below the discount rate, for example, then the net present value is smaller than 0, then the project can be considered not economic. On the other hand, if it's above the discount rate, especially when it's substantially above the discount rate, then the net present value is bigger than 0, and then it can be considered a, say, financially feasible project. IRR can also be used for checking whether certain loan rates, certain loans with certain loan rates can be considered for project financing. Say in principle, if the IRR, as long as the IRR is above the interest rate, then a project should be able to cover the servicing of debt. So it should be able to pay off a loan with interest. Return on investment is similar to the internal rate of return, but then applied to the amount of capital that's invested by investors, and looking at the actual financial returns for the investors. So if a project owner only needs to invest, let's say, a fraction of the investment cost, if he needs to cover only a fraction of it by his own means, by equity, and the other would be covered by loans and grants, for example, then his invested capital is a lot smaller than the total project investment. On the other hand, some of the financial returns that he has may have to be used for covering interest payments, loan repayments, and tax payments. So they can be smaller than the actual project returns, and then the consequences of these adjustments will result in a different rate of return. And then we talk about the return on investments. The levelized cost of energy. Don't really think we have the time to look at it closely. I present here the formula. Basically, you look at the net present value of all the project costs. So not the net cash flows as we do when looking at the NPV, but with the LCOE we only look at the project costs, and we also look at the present value of all the energy generated during its lifetime, and the ratio of the two is the levelized cost of energy, and that can also be used for comparing the generation cost of different electricity generation options. I think I'll leave the depreciation for what it is. Modeling very briefly. What you will see in general cash flow models is that you combine the investment cost, the operating cost, and the revenues of a project. Use them for building up the cash flows, for looking at the cash flows in different years of the project operation period. And you can start using that for calculating financial indicators. A further step could be to look at the project financing, where do you only look at equity invested by the project owner, or also at grant financing and loan financing, and look at the financing cost that come from that. They will provide further inputs for the cash flow model. You can have a look at amounts of working capital that is needed for running the project, so in order to cover a number of months of expenses to bridge a certain number of months of anticipated returns for the energy supplied. You can have a look at the depreciation of assets, depending on the investment cost, the expected lifetime of the assets. And you use that together with operating costs and revenue to determine the profits and losses, profit and loss account during each year of the project's lifetime, that you can use for calculating the amount of tax that may be due depending on the profits made. And that again can be used in the cash flow. You can determine the production cost. So operating costs would be one part of it. Financing cost and depreciation would be other parts of the production cost, and that may change from year to year depending on or particularly how your project is financed. And finally, it's possible to prepare the balance projection for each of the years of the project by taking information from the profit loss accounts, from looking at the investments and looking at the way that a project is financed. That's it for this session. As I said, we will be looking closer at the different aspects, and we'll be doing some exercises in let's say further sessions starting mid-January. Yeah, I don't know if there's any questions on today's session.